Welcome back. In the last class, we have discussed about different cases that comes under the binomial distribution situation, where we have learned how to find the percentage of a certain probability of an event, and also we have learned to find out the number of times an event occur on the base of the probability value. From probability value, you were able to identify the number of times a particular event has occurred. Let us discuss some of the other important cases comes under the same category. Previously, we have discussed about how to find the number of times a particular event on the basis of your probability value. Let us go to the other important areas. Next one. It is an important property. I have shown the list of properties with regard to binomial distribution, and I have mentioned that during the course of a study we will come across different properties with regard to our case studies. So one of the properties that mean of a binomial distribution is the product of n and p. We all know what is meant by n, and p is also we know. And at the same time, if you want to find the standard deviation of a particular distribution, especially binomial distribution, the equation is root of npq. Sometimes you may come across a question where you will be given variance. If it is a variance, then you have to remove the root. We all know what is the difference between standard deviation and a variance. We are not going any further into that. Just go through the previous cases if you have any doubts with regard to the standard deviation. Let us do some cases with regard to mean of binomial distribution and standard deviation of binomial distribution. So remember these two equations. Next one, bring out the fallacy in the following statement. The mean of a binomial distribution is 5 and the standard deviation is 3. Prove that the statement is correct. So the term bring out the fallacy. Fallacy means make sure that whether the statement is a true or false. That is the meaning. Fallacy, true or false, truth or false, likewise. So bring out the truth or false in the following statement. Statement is that we don't know about the distribution, but it said that out of a distribution, the mean of that particular distribution is 5, and the standard deviation also of the particular same distribution is 3. You have to prove that that distribution was binomial distribution and the distribution is correct or not. So how you are going to find? It's an application level cases. You may come across this type of questions. Don't worry, just understand the concept. Once you get the concept or logic, you will be able to deal with the similar type of questions. So first of all, let us note down the details given in the question. Here mean of the binomial distribution is 5, and we know that the equation of mean of a binomial distribution is np. So mean of a distribution, especially a binomial distribution, is np, and the value is given as 5. We just note down the data given in the question. Similarly, standard deviation also is given. Standard deviation is 3. We know that standard deviation is root of npq. So standard deviation is 3, then the variance of that value will be 9. 9 means if you take out the root, you will get the whatever the number and its square. So 3 is root of certain value, you have got 3. That means the npq was 9. I hope you are getting the concept. So on the basis of data given in the question, we found that mean is 5 and standard deviation or variance is 9. So we can assume that if npq is 9, we found that npq, here it was root of npq equal to 3. We have removed the root, then the value npq is 9. So npq is 9 as per the details given in the question. So let's substitute the value of 5 in this NPQ. We know that NP is 5. So we can write as, instead of NP, we can write 5Q. So you will get Q equal to 5Q equal to 9 and Q equal to 9 by 5. And if you solve that Q, you will get 1.8. So we have found the result of the particular distribution, and now we have to make the statement. That is very important. Whether the distribution under the study, whether it is true or false. So how you are going to find whether it is true or false? That is the next most important property of a binomial distribution. The property of a binomial distribution is that if you add the values of P and Q, we all know what is meant by Q. If you add the values of P and Q, the result will be 1. But on the basis of your analysis, we can see that the value of Q with regard to this statement is 1.8. How can it be like that? In the question it is said that the binomial distribution of a certain event or whatever it is 5 and 3. Mean of binomial distribution is 5, standard deviation is 3. So how we are going to find out? So here you got the value 1.8. An important property of a binomial distribution is the value of Q will be less than 1, because sum of P and Q is 1. Then how can value of Q is 1.8? It's above 1. So we can say that the statement is wrong, because Q cannot be greater than 1. It should be a value less than 1, because we have learned that one of the property of a binomial distribution is that if you add P and Q, you will get 1. That was the concept. So the statement is wrong. So sometimes you come across a question where you have to prove whether the distribution is correct or the values is correct. So you need to familiarize the properties with regard to that, and remember each of the equations and cases which we are dealing under the analysis. So let us go to the next one. Another case, for a binomial distribution, mean is given as 4 and the variance is given as 12 by 9. Write down all the terms of the distribution. So all the terms of a distribution, what are the terms? The terms are, it's very simple. What is the value of P? What is the value of Q? What is the value of N? These are the main terms in a binomial distribution formula. So you need to identify all this. And how we are going to identify? You have to find on the base of the mean and variance is given. So let us extract the data given in the question. Here mean is given as NP. We know that mean of a binomial distribution is NP. So NP is 4 and variance is written as NPQ. We have learned that standard deviation of binomial distribution is root of NPQ. Otherwise it can be represented as variance equal to NPQ, that is 12 by 9. So we have one mean that is given in the question, mean NP equal to 4, and another is variance, that is NPQ equal to 12 by 9. So we have to substitute the values here on the base of the equations given. So we can say that by solving the equation by substituting the NP in NPQ, we have done the same step in the previous case. NP is 4, here NPQ is 12 by 9. Just substitute the value of 4 in this one. So instead of NP we can write it as 4. So 4Q equal to 12 by 9. So the value of Q is 1 by 3. So you have got the value of 1Q. If you know the value of Q, you can easily find the value of P, or vice versa. So the value of P is 1 minus Q, because we have learned that if you add together P and Q, you will get 1. So P equal to 1 minus Q, and we have already found the value of Q. So 1 minus 1 by 3, you will get 2 by 3. So now we have Q and P. Now the only term that we have to find is N. See, and in the question it is said that mean of that particular binomial distribution is 4. That is NP equal to 4. And we have just found the value of P. So if you know the value of P, and if you substitute the value of P in this equation, you can easily find the value of N. So this is how you have to find various terms with regard to a distribution. So we know that NP equal to 4, and we already found the value of P. So N into 2 by 3, that is value of P, you will get N equal to 6. So we have N value is 6, and the value of P is 2 by 3, and the value of Q is 1 by 3. So now we have found all the terms with regard to that. And you can even write down the values or the value of X under the study, because we have got the value N equal to 6. So the number of items in X, or whatever the event under the study, it will be 1, 2, 3, 4, 5, 6. And 0. Remember, in a binomial distribution, when you are asked to find the probability of a certain event, we will always begin with the 0. So in the N will be 6. So if you add together 1, 2, 3, 4, 5, 6, 7, there will be 7 items, because we have to include the 0 event also. In a binomial distribution, you will be dealing like that. If the N is 6 events are there, you have to study the event of not occurrence also. So it will be 0, 1, 2, 3, 4, 5, 6. Don't get confused. N is 6, that is right. 1, 2, 3, 4, 5, 6. But you have to also study the probability of occurrence of non-event. Non-event means event not occurring. In all the cases, you have to study that. It's one of the properties of binomial distribution. Remember the properties of binomial distribution. There's a slide which we have discussed previously in some of our last class. So just go through the properties. Now we have found the value of Q, value of P, and N equal to 6. We had also mentioned about 0, 1, 2, 3, 4, 5. We also mentioned that. Now the question, for a binomial distribution, its mean is 4 and variance is 12 by 9. Write down all the terms of the distribution. So now you have to find the probabilities of each of the individual events. Individual events in when the event is 0, what is the probability? When the event is 1, what is the probability? Event is 2, what is the probability? Likewise, you need to find all that. Then only your answer is complete. So now we have found out all the requirements of finding the probabilities each of the events. We need P, we need Q, we need N. So let us write down or identify the probabilities of each of these events by using the binomial distribution function of NCX, P raised to X, and Q raised to N minus X. So N is 6, P is 2 by 3, Q is 1 by 3, and X is 6 events including the event 0. So we will write like this. When the X is 0, by using the binomial distribution situation, you will get the value of the probability of that non-event is 1 by 729. I hope you know how to find the probability with regard when the X is 0. Just substitute the necessary values in the equation. I am not going to explain the same situation again and again, because we already know how to find the binomial distribution with regard to the probability. So when the X is 0, the chance of occurrence is 1 by 729. Next one, when the X is 1, the probability of getting 1 as a successful event is 12 by 729. So you need to remember that when you got N equal to 6, consider the event 0 also, because under the study we are not discussing about 0, but you need to include the probability with regard to 0. See, we begin with 0. but the number of items is 1, 2, 3, 4, 5, 6 as per the value which we have found. So next one, from here on our probabilities of events we have to study. If the x is 1, you have got the probability as 12 by 729. Next one, when the x is 2, substituting the various 2 in some values where or variable where x was there, 6c2, 2 by 3 raised to 2 and 1 by 3 raised to 6 minus 2, you will get 60 by 729. Likewise, when the x is 3, it will be 6c3 into 2 by 3 raised to 3 into 1 by 3 raised to 6 minus 3, you will get 160 by 729. Next one, when x is 4, it will be 6c4 into 2 by 3 raised to 4 into 1 by 3 raised to 6 minus 4, you will get 240 by 729. I hope you all know how to find or how to solve this one, 6c4. It is almost similar to the method which we have learned in the case of permutation combination, and I hope you know how to find what are the NCX situation, or here it is 6c4. If you have any doubts, just go through the combination situation or the theoretical and cases which we have discussed previous sessions. And when x is 5, it will be 6c5 into 2 by 3 raised to 5 into 1 by 3 raised to 6 minus 5. And next one, when x is 6, it will be 6c6 into 2 by 3 raised to 6 into 1 by 3 raised to 6 minus 6. It will be 64 by 729. So now we have found the probabilities with regard to each of the events by using binomial distribution function. So now we have found all the terms of the distribution. This is how you have to deal with the situation or cases with regard to binomial distribution. So we have learned to find P, Q from and N from NP and NPQ, that is mean and variance, and on the basis of it we have found how many items are there under study. We found that there are 6 items or 6 events. Apart from that, you need to consider another one, 0. When there is 0 event occur, we have to find out that one also. In some situation or some cases or different texts, you can see that the study with regard to 0 event will not be mentioned. So this is how you have to find the probabilities of each of the events on the basis of all the values by using binomial distribution function. Let us go to the next one. Another case. For a binomial distribution, again the same situation, with n equal to 6. And the third term is 9 times the fifth term. Find the value of P. So how you are going to find the value of P? It's an application level question and it's quite tricky. You may find it confusing in the initial glance, but don't worry, we will deal with it. So as per the details given in the question, it is said that n is 6. So n will be 1, 2, 3, 4, 5, 6. Okay, and we also include the 0 event. I hope you all know why 0 came. Next one, the third term is 9 times the fifth term. So the third term means 1, 2, 3. So third term is at x equal to 2. And in another case, fifth term where x equal to 4. And remember, in some texts, I have mentioned earlier about that, in some texts they may not include 0. In that case, it will be 1, 2, 3, 4, 5, 6. In that case, the value of x will be different, and x here also value will be different because there is no 0. And in that case, the answer will also be different, even though the question remains the same. So it depends upon the value 0 included or not. Some may include, some may not include, so the value remains different, and the answer also becomes different for each of these cases. So how you are going to deal that situation? So whenever you come across a question like this, just give a note or a description with regard to why 0 is included. Because in a binomial distribution, apart from the events that are occurring, we need to find the probability of a non-event. Non-event means 0 event. That is why 0 is included. If you give a note like that, then you are safe. So remember to give a short note with regard to why you included 0. Okay, let's come back. So the third term is x equal to 2 and the fifth term is x equal to 4. Fifth term is 1, 2, 3, 4, 5. So in the question it is said that the third term, this one, is 9 times the fifth term. So we can write down the same during the application case. So let us come back. So the third term is x equal to 2. So the binomial distribution function of third term, that is s equal to 3. Sorry, x equal to 2, because we already found that the third term is 2. So x equal to, if you substitute the same in the binomial distribution equation, it will be like this. N is already given in the question 6, so ncx, x is 2, so nc 6c2 into we don't know about p, so let it be like that, p raised to value of x, that is 2, into q, let it be like that because we don't know about q. Q also we can write that n minus x, we know that n is 6 and x is 2, so we have got this one, let it be like that because we can't go any further with that. Next we will do another step. Okay, next one, like that we need to find the binomial distribution with regard to the fifth term. So binomial distribution function of the fifth term is x equal to 4. So it can be written as the similar method which we have done just now, 6c4 into p raised to 4 into q raised to 6 minus 4. So let it be like that, don't go any further. So once you come across a question like this, you need to write down the binomial distribution function on the base of the data available. So once you found like this, next step is you need to do like this, because in the question it is said that the third term is represented like this. See, it is written like this. Third term is 9 times the fifth term. So 9 times the fifth term is 9 into fifth one. We already written in a binomial distribution form. So now the statement is just like the description given in the question. See, 6c2 into p raised to 2 into q raised to 6 minus 2. That is the binomial distribution function of third term. We just write down like that instead of writing 2 equal to 9 into, because it is said that 9 times the fifth term. We already found the binomial distribution function of fifth term. So it will be 9 into 6c4 into p raised to 4 into 6 minus 4. So it can be written as 6c2. We can solve that one. So let it be 15 into p raised to 2, we are helpless, and q raised to 4. 6 minus 2, 4 equal to 9 into again 6c4. It can be written as 9 into 15, 6c4. If you solve that, you will get 15 into p raised to 4 into q raised to 2. Just like the left hand side, we have done the same in right hand side also. Now by solving the both side using the basic mathematical step of knowing the known value in one side and unknown value likewise, you will get that q square or q raised to 2 equal to 9p2. You may think that how did I came to that statement or the base of the just preceding one. It is just like this. This one is almost similar to a situation where 6 equal to 2x. Then what I will do? X equal to 6 by 2. Just like that. 15 to p2 raised to q4 equal to 9 into 15 into p raised to 4 into q raised to 2. I just done like this. I have shifted this entire expression, this 15 into p raised to 4 into q raised to 2, into the denominator of this one. That's like this, 2x equal to 6. So x equal to 6 by 2, just like that. So 15 and 15 will be cancelled, and here numerator is P2, denominator is P4, then the P2 and P4 will be cancelled and there will be remaining P2 in the denominator, and in the numerator Q4 and denominator is Q2, so denominator Q's will be cancelled because there are only 2 Q's, and in the numerator there are 4 Q's. So finally you will get 9Q equal to, or 9 equal to 15Q raised to 2 divided by 15P raised to 2. So by solving those steps I will get Q raised to 2 equal to 9P2. This step is actually a simple mathematical step, that's why I am not including that. So by solving that I will get 9 raised to 9 raised to P raised to 2. So now you have to do is like this. We know that Q is equal to 1 minus P. So instead of Q raised to 2 I will write 1 minus P raised to 2. And I done that step in order to make the both sides same variable. Here it is Q, here it is P. If I do like this I will get both P in both sides. So 1 minus P raised to 2 equal to 9P2. So 1 minus P raised to 2 is an important mathematical function, that is a minus b the whole square. So using that equation a minus b the whole square, I expand this bracket, I will get 1 minus 2p plus p raised to 2 equal to 9p2. Let it be like that. So let us solve again by converting the various items to the respective sides. I will alter this step by changing the position of certain variables to certain sides. See, 9p is shifted to the left hand side, and now it will be 8p2 plus 2p minus 1 equal to 0. Why I have done like this? Because if you look closely you can see that it is almost similar to a function which we have learned in one of our sessions in third sum. We have learned about quadratic equation. If you remember that method, this is almost similar to that one. So on the basis of quadratic equation you need to solve this one. You may think that quadratic equation is not a part of our syllabus. Still, sometimes we may come across some application level question where we have to use some of the methods we learned previously. So remember the method quadratic equation, you have to remember that case. I am not again explaining that quadratic equation because we have done numerous questions and cases regarding quadratic equation previously. Just go through those slides, then you will get a clear picture. So once you understand the quadratic equation function, then come back to this case. So I am by using the quadratic equation function, I got that P is 1 by 4 and 1 minus 1 by 2. So what is meant by 1 by 4 and minus 1 by 2? In a quadratic equation, there is a sign in the equation that plus or minus the equation part. So you will get a value, two values. One may be positive value, another may be negative value. So by using the quadratic equation, I have got that one is 1 by 4, another is minus 1 by 2. So I am trying to find the value of P. So the value of P means it should be a number that is less than 1 and it should be a positive value. That is one of the properties of binomial distribution. So P cannot be a negative number. So minus 1 by 2 will not be an answer. So the value of P is 1 by 4. Once you find the value of P, you can easily find the value of Q also. In this question you are asked to find the value of P alone. So you just have to do until here. Sometimes you may come across a question where P and Q is given. So once you found the value of P, you need to find the value of Q. That's very easy. The thing is that sometimes in some of the application level questions you may come across questions where you have to use the methods which you might have learned in the previous semester or our first semester, whatever it is. Familiarize with the problems and cases which we have learned until now. And this type of questions are very rare with regard to your examination point of view. still you need to prepare well for the cases like this. So just go through the case, understand the concept, refer the previous sessions and the third sem portions. If you have any queries, please let me know. We will continue with the further in the next one.